Hello everyone, welcome to today's session. I am Professor Monika Raghuvanshi, Department of CSE AML, and in this video, I will be explaining the topic Fundamental of Artificial Intelligence. So let's get started. Artificial intelligence, or AI, is one of the most exciting and fast-growing technologies. In today's world, it's changing the way we live, work, and interact with machines. So let's begin and understand what AI really is and how it works. Let's start with the basic question. What is artificial intelligence? The term artificial means man-made, something that is created by humans, and intelligence means the ability to think and make decisions. So artificial intelligence refers to intelligence created by humans, which enables machines to think, learn, and solve problems just like humans do. In simple words, we can say that artificial intelligence means the ability of a computer or machine to think and learn like a human being. Just for example, when you ask Google Assistant or Siri a question and it gives you an answer, that's AI in action. Some real world example: AI is used in self-driving cars to detect traffic signals, in Google Assistant to understand our voice, and in Netflix to recommend shows based on our watching habits. So basically, AI tries to make machines smart. As you can see in the diagram, which shows the basics of artificial intelligence. Now, let's take a quick journey through the history of artificial intelligence and see how it all began. So, artificial intelligence is not new. It's the result of centuries of human imagination and decades of innovation. The story of AI started in 1950 when Alan Turing, a British mathematician, introduced the famous Turing test. This test was designed to determine whether a machine could think and respond like a human being. Then, in 1956, John McCarthy coined the term artificial intelligence. During the Delft conference, this event is often called the birth of AI as a field. Now, in 1960s and 70s, early AI programs like Eliza, a chatbot that simulated conversation, and Shadlu, a program that understood simple English commands, were created. These were the first steps towards natural language processing and intelligent communication. Now, moving to the 1980s, AI research focused on expert systems which could mimic the decision making ability of human experts. For example, systems like Mycin helped doctors diagnose diseases based on symptoms and rules. In the 1990s, AI began entertaining the real world. Remember, IBM Deep Blue, the computer that defeated world chess champion Garry Kasparov in 1997. That was a historic milestone showing machines could outperform humans in complex tasks. From the 2000 onwards, the rise of machine learning and deep learning brought a revolution. So, the inventor of artificial intelligence is John McCarthy because he was the one who founded and named the artificial intelligence. Modern tools like ChatGPT or Tesla Autopilot are the results of this long AI evolution. That's all the diagram which represents the history of artificial intelligence. Now, why do we need artificial intelligence? What's the motivation behind that? We must know that. So first and biggest motivation behind AI is to create machines that can think and act like humans. Just imagine a computer that can understand language, recognize images, or even make decisions. That's exactly what AI is for. For example, think about Siri or Alexa. They can understand what you say, answer your questions, and even make jokes, just like a human assistant. Next, to reduce human efforts and save time through automation. AI helps in automating repetitive and time consuming tasks so humans can focus on more creative and meaningful work. For example, in factories, robots perform tasks like assembling cars much faster and more accurately than humans. This saves both time and effort. Next is to increase accuracy, speed, and efficiency in different tasks. Machines powered by AI don't get tired or distracted. They can work continuously and perform tasks with high accuracy and speed. For example, in healthcare, AI can analyze medical scans like X rays and MRI reports faster than doctors, helping in early disease detection. Next one is to analyze and understand large amounts of data quickly. Today, every second, huge amounts of data are generated on the internet. It's impossible for humans to study it all, but AI can. For example, platforms like Netflix and YouTube use AI to analyze what people watch and then recommend videos or shows you might like. Next one is to perform complex tasks that are hard for humans. Some tasks are too dangerous, complex, or time consuming for humans. But AI systems can take over such jobs safely and efficiently. For example, AI powered robots are used in space exploration, underwater research, and even in dangerous rescue missions where humans can't go easily. Now, the last but to improve quality of life and support innovation in modern technology. Finally, AI aims to make life easier and smart. From smartphones to self-driving cars and language translation tools, AI is improving every and transforming industries. For example, AI in smartphones controls lights, temperature, and security systems, making our homes more comfortable and safe. Now, AI is transforming technologies everywhere. Self-driving vehicles uses AI to make driving decisions. Virtual assistants like Siri and Alexa respond to voice commands. Healthcare systems uses AI for medical diagnosis. Predictive analytics helps businesses forecast demand. Chatbots improve customer services. For example, Amazon's recommendation engine and Google Maps real-time traffic updates are excellent uses of AI. That's all contribution of AI to modern technology. Next, what is an agent? An agent is a computer program, as you can see in the diagram, that perceives its environment through sensors and acts using actuators to achieve a goal. So actuators will basically perform the actions to achieve a goal. For example, a robot vacuum cleaner is an AI agent. Its sensors detect dirts and walls, while its actuators control movements to clean efficiently. Basically, actuators will perform the actions. Next, what is production AI system in AI? So it is a rule-based model that is used to represent knowledge and solve problems. That's basically components that which you can see in the diagram. Working memory, which will store current facts or data, production rules, if-then rules for decisions. For example, if traffic light is red, then stop the car. Control system applies the correct rule based on situations. For example, expert systems in medical diagnosis uses prediction system to suggest possible diseases based on symptoms. Next topic is there are different types of search algorithms that are used in AI. Search algorithms helps AI find paths or solutions efficiently. They are divided into two categories, uninformed search and informed search. Uninformed search, there will be no heuristic or prior knowledge, but in informed search that uses heuristics to guide search. Uninformed search, that is also known as blind search. Informed search, that is also known as heuristic search. For example, GPS navigation uses informed search to find the fastest route to your destination. So basically, we will elaborate uninformed search and informed search one by one. First is breadth-first search. It will explore all nodes label by label using a queue data structure, that is FIFO, first in, first out, which guarantees shortest path if all costs are equal. As shown in the diagram, it will visit breadth-wise. So the path will be 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, then 6, then 7. Next is depth first search. Again, it's the part of uninformed search. It will explore as deep as possible before backtracking. Uses a stacked data structure, which uses the concept of LIFO, that is last in, first out. But it may not find shortest path. It will visit depth-wise. First, it will visit 0 to 1, then 1 to 4, 4 to 5, then 2, 2 to 6, then 3, then 7. Next one is uniform cost search. Cost search again is the part of uninformed search. It will expand the node with the lowest cumulative path. Uses a priority queue. It is optimal for positive cost. So it will traverse from G to D, D to B, B to A. So the optimal cost will be G to D, D to B, B to N, B to A. Now let's start uninformed, informed search. Informed search. First is best first search. Best first search, select the node with lowest heuristic value. As shown in the diagram, it will traverse from A to C because from A to C, the lowest heuristic cost is given, that is 25, and then from C to F, then F to G. The optimal cost will be A to C, C to F, and F to G. Next is real timing search. It's a heuristic search that continuously moves towards increasing value and stop the search once it moves to the local maximum, as you can see in the diagram. Next is A star search. It uses the evaluation function, that is f of n is equals to g of n plus h of n. G of n is the cost to reach current node and h of n is equals to estimated cost to goal. So let's understand what's g of n and h of n from the diagram. So from S to A, the g of n value will be 1, and from S to B, the g of n value will be 2. So that's basically known as from start node to next node. And the h of n value will be estimated cost from start node to goal node. So here the h of n value for A is 5, and for B, the h of n value will be B. So one by one, whole values are given in the question. And we will expand the nodes from first S to A, then S to B. One by one, whole nodes will be explored. So here, the best path optimal cost is S to A to X, and X to E. That's all. Next is AO star search algorithm. It works on and/or graphs to solve problems with sub-goals. It evaluates multiple paths simultaneously. Means if AND arc is connected, if AND arc is present here, means here A to C and C to D, and arc is present there. So this path will be counted simultaneously, and A to B will be counted one. So here The path will be updated one by one. So here the optimal cost will be A to C and C to D. And cost is 6. The path will be A to C and C to D. So I hope it's clear to you all. So in this session, we covered the fundamentals of AI, including its meaning, history, motivation, production systems, and various search algorithms. Let's conclude with the line: AI continues to shape the future through innovation, automation, and intelligent decision. I hope it's clear to you all. Thank you.